Hey guys, welcome to my video. I'd like to show you my progress working on this tiny little robot. Okay, this is a Raspberry Pi robot. As you can see here, this is my Raspberry Pi 3. And on top of this Raspberry Pi is the motor controller, made by ZeroBorg. And this is the most basic controller, which is the ZeroBorg version. Okay, this motor controller is the alternative to our normal controller using the L298N chip. This is a far superior controller because it is using the I2C protocol. And this controller is capable of driving 4 DC motors. As you can see here, 1, 2, 3, 4. You have 4 terminals for DC motor connection, and the middle part is used for power supply. Okay, and this power supply is coming from 6 rechargeable AA batteries, okay, which will total up to 7.2 volts. And okay, at the front of this robot, okay, this is the front side of my robot. I have this Pi camera mounted on 2 S90 servos. Okay, and here I have this pan and tilt, okay, movement, courtesy of this plastic mount. So I have this 2 degrees of freedom movement for my camera, and next to this camera is a laser module. Okay, this is the signal line and the ground terminal, so you can use it for aiming or any interesting project that you could think of. And underneath this robot is a proximity sensor, a distance sensor mounted on a mini breadboard, okay, the yellow breadboard here. And also I have 2 super bright LEDs, okay, mounted on this breadboard. And on top of this robot also I have another mini breadboard, okay, used to connect my servo to the Pi. Okay, this is the cable coming from my tilting servo, and on the other side this is the cable from the panning servo. So they are all connected to this breadboard, and from this breadboard I use another jumper to connect them to the GPIO pins. And other than that, okay, this is the connection for the ZeroBorg itself. So only 6 jumpers needed to make a complete connection between ZeroBorg and the Pi. Okay, they actually basically uses all the supply pins on this Raspberry Pi, the 5-volt pins, and also the 3.3 volt pin. And other than that, it is also connected to the I2C pin, which is the BCM2 and BCM3 of your Pi. BCM2 will handle the data transfer, and BCM3 is for the clock. So at the back here I have a small trolley wheel which I jam it with these two cable ties. I do not want it to move around. The reason is it will interfere with my steering movement. And last but not least, okay, this is a power bank used to power up my Pi. So basically I have two different modes of supply. Okay, the 6 AA batteries will function to power up this motor controller and also to handle these two DC geared motors, while the power bank is only used to power up the Raspberry Pi, because I want to have a very efficient and constant power delivery to the Pi. So I do not want to share one power supply for two different purposes. But if you have a proper DC to DC converter, DC to DC level converter, you can use that. So you do not have to buy a power bank for your robot. So that's basically it. A two-wheel drive robot. Okay, in the later video I will show you how I control this robot, and okay, I am using this DualShock 4, okay, made for PS4, and it will be driven via Bluetooth connection. So you will see in the later video how I program this robot, but just the basic part of the programming because the programming for this robot is quite complex, but the complexity mostly comes from the ZeroBorg program itself. For the overall algorithm is not that complex. I will show you in a later video. So I guess that's all for now. In this video, I would like to show you how to connect your PS4 controller to the Raspberry Pi. Okay, but the installation procedure has been made in another video. So if you'd like to learn how to install the driver for the PS4 controller, you need to watch that video, because I am not going to repeat that procedure for this session. So let's move into the desktop view. Okay, the driver for the DualShock 4 is called DS4 DRV, and the way you run that driver is by writing this command sudo ds4 drv, and then I would like to run this command in the background, so I just put the ampersand symbol, okay, which is the and symbol at the end of the command. So then you press enter, and right now the driver is running in the background. As you can see, it has created a device, okay, device input JS0, and it is currently scanning for devices. So this is the time for you to turn on this controller, and in order to make this pairing process, you have to press the PS button with share button simultaneously. So let's press it right now. Okay, you press and hold until you see the lights blinking. Okay, so right now the LED light is blinking and it has turned into a blue color, and on the screen right now you are looking at this pairing requested. Do you accept the request? You just click OK, and then it will produce this connection failed error. I do not know what's the problem with this GD bus error. Operation not permitted, it says. Try to connect manually, but just ignore that error because you have successfully connected to the controller. Actually, you see at your terminal, you will be presented by this battery status and signal strength status. It says here signal strength is low. I do not know how to improve the signal. The signal is always low for this pairing process. So right now the controller is fully connected to the Pi. So how to test this controller? Okay, you open up a new terminal and then you simply type in this command. Okay, JS test. You access the dev directory and then you go into input and you search for JS0 input. So here it says driver version 2.1.0 at the time of recording this video, and joystick Sony Computer Entertainment wireless controller. So it recognized this controller as DualShock 4, and it has 14 axes and all those axes named, and 14 buttons. So you can try to click. Oh, this is not working properly. Okay, let me exit this command and try to run this command again. First we clear the screen and then just test. So it kind of fell for now. So okay, let me restart the pairing process once again. Okay, let me restart the process. So I have to get the ID for this process, which is 23400. So I need to kill this process by using sudo kill -9 23400. So let's check again. Okay, we have killed that process, and your PS4, you should turn it off because we need to restart this pairing procedure. Okay, this is normally happen for me. I do not know why, because the first time doing this pairing process, okay, we will face this error. I'm not sure the reason behind this error. So let's try again. Okay, I have two terminals currently open. I can use either one. Okay, sudo ds4 drv and then you press N, and it is currently running in the background, and then I press the share and PS button at the same time and hold them together until you see the light blinks, and just wait for it to turn blue. Okay, your controller is now connected, and then we can try again the JS test command. I just look for the command. Okay, you just press the up key on your keyboard to access your previous command that you have entered. Alright, okay, now we have fully connected to the DualShock 4. As you can see, this is the blue LED. It's saying that it is fully paired with the Raspberry Pi. So on your Raspberry Pi, you can try the JS test command to see if it is really receiving the input from the controller, and be informed that my driver is currently running in the background. As you can see, it is showing all these status or debug report. Okay, so my battery is currently at 87, I think. So we can use this command to test out our controller. So there you go. You can see that if I press, is it jammed? Okay, it's currently jammed for some reason. Not sure why. Okay, so let's try this again. Okay, let's run this JS test. Alright, now it's fully working. So here, if I doodle with this right joystick, so you can see I am changing the value of axis 2, and this left joystick is changing the axis 0 and axis 1. Actually, axis 1 handle the up and down, okay, movement. Okay, if you push it all the way to the top, you will get that negative 32,767, and when you press it downward, you will get a positive value. So for axis 0 is related to the left and right movement of this left joystick. So the same goes to the right joystick. Okay, you are changing the axis 2 and axis 5. I do not know if you can change this value in the configuration file. Maybe you can change it. You just look at the documentation for more info. So that's basically it. Now I can use this controller. Okay, as you can see, as I press this R2 button, the axis 4 value changes, and L2 changes the value of axis 3. So you can use this value to control your robot, okay, later on in your Python program. So we will use a Pygame module which will handle this controller input, and I will show you how to create your own robot. So in a later video or in another session, I will show you how to program, how to compile all those programs, okay, to handle ZeroBorg controller, to handle this controller input using Pygame, and also we will play around with this little camera. Okay, I will be using OpenCV as well for my autonomous project, okay, which is the simple line following robot, okay, using this camera. So stay tuned and thanks for watching. Alright, so now let me show you what can be done with that PS4 input. So I will control this robot using this PS4 controller. I have the code already written in the Raspberry Pi. I will show it to you later, but first let me switch off the controller, and then let me insert all these batteries. Alright, okay, so now we are ready to operate this robot. So on this Raspberry Pi inside your desktop view, so I have my code located in ZeroBorg folder. Okay, and the name of that code is joy test. So I have to run this code using the Python command python joy test. Alright, so okay, this robot is going to run forward if I run this, but it is currently turned off, so it won't do so. So okay, this code is currently running. So if I press this on button on the robot, this on button, you can see the wheel will start spinning. Okay, as I press any button on the DualShock 4, it will stop spinning because that is actually the problem with the code itself. Okay, I still cannot find a way to stop the wheel from spinning whenever I run the code. There is some issue with the input itself, which automatically set this R2 trigger to maximum value. Okay, but as you press any button, you will stop the wheel from moving. So now we can try this robot. I'll need to put this robot on the floor. Okay, so here we go. This is the robot. Alright, let me just move it slightly. As you can see, I'm moving the robot. Okay, and I am actually pressing the R2 to control the robot. Oh, so I use the left joystick to turn the robot left and right, and I use the R2 trigger to accelerate forward, and to reverse the robot I need to press the L2 and the R2. Okay, the L2 will invert the wheel rotation, so it will reverse the robot, but if you just press the R2, it will move forward. So another code that I would like to show you is more interesting, okay, which can handle the servo. So let me run that code. Okay, so the code is Python laser joystick test, I think. Okay, so right now, as you can see, the servo is currently jittering. Okay, if I move this joystick right side, the right joystick will control the servo, as you can see. So I can also drive the robot. It's hard for me to record this. Okay, so I'm using this. What is that sound? Okay, and I can also turn on the laser beam. As you can see, the laser is turning on. Can you see that? Okay, let me show you. No, you cannot see that. Alright, let me point this robot towards the cable. So if I press X, I activate and deactivate the laser. Alright, so you can do so much stuff with all this button. Okay, for now I am only controlling that one LED, one laser, so you can use it to control other components such as LED, buzzer, and whatever you like to use. So that's basically it. I just want to show you what can be done using this wireless Bluetooth controller with your Pi. So in the next video I will show you how to code this thing. So thank you for watching and stay tuned.